Hello students, welcome back to the class. Okay, so first of all, there was an issue to yesterday. Because of that, you won't be able to chat. So sorry for that. So let's see our today's class, and I will make sure that if you have missed something in the previous class, we'll try to do it as you were not able to ask the question because of some technical issue. So today what we will do is first of all, start with the JEE PYQ of the some basic concepts of chemistry. Okay, we'll start with the JEE PYQs of some basic concepts of chemistry, and then we'll go back and look at the topic which was eudiometry, and it was not covered wholly because of some time issue. So I will try to cover that also. So let's start this. Disclaimer that images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of the original creators and owners. If you are the owner and have any concerns or issues, please contact us at sathee@itk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using generative AI, which is experimental. So here is your first question. So this question is for the 2000 mains exam, and it was asked in the 12th April first shift. The question is 5 moles of AB2 weight 125 into 10 to the power minus 23 kg and 10 moles of the A2B2 weight 300 into 10 to the power minus 3 kg. The molar mass of A, which is represented by capital Ma, and the molar mass of B, which is represented by capital MB, in mole in kg per mole are. So 4 options are given for you. I'm giving you some time to think over this question. Then we'll look at the solution. So there is a question from one student that whether the JEE PYQs are helpful for NEET aspirants or not. So I would suggest you that if you have enough time, you can go through these questions. It may help you to build up the concept. But at the same time, I would suggest you that please go and practice questions of NEET PYQs. If you are lacking time, then we will have the NEET PYQs after 2 consecutive JEE PYQs. Just wait for that. So everyone, I'm starting the timer. So you can just try it by yourself. I'm getting the answer as option D. So those who have a doubt in yesterday's class, we will cover that part also in the later on part of this lecture if we have time left with us. Okay, so let us look at the question. The question is saying that we have 2 compounds which are AB2 and A2B2. Okay, and AB2 has 5 moles. And this 5 moles of AB2 has a mass of 125 into 10 to the power minus 3 kg. Similarly, A2B2 has a weight of 300 into 10 to the power minus 3 kg, where the number of moles is 10. You have to calculate the molar mass of A and B. Now let's see how we can solve it. Remember that the answer should be in mole per kg. If you do kg per mole, if you do so, then the molar mass of A comes out to be 5 into 10 to the power minus 3, and the molar mass of B comes out to be 10 into 10 to the power minus 3. So that is option number D. How we'll solve it? So from this table, you can get an idea that what are the variables that we are using. So we are taking it according to the question only. So we are taking the molar mass of A as Ma and molar mass of B as Mb. If we are doing so, then what is the mass of A that is present in 1 mole of AB2? It will be Ma. And what is the mass of B that will be present in 1 mole of AB2? It will be 2B. But in the compound A2B2, we have 2 moles of A, therefore the total mass of A will be 2 into Ma and the total mass of B will be 2 into Mb. Now next, what is the formula for number of moles? It is given by number of moles is equals to given mass by molar mass. Then what we can say? We can say that N into M is equals to W, that is number of moles into molar mass is equals to weight. If we consider this as the equation A, then equation A can be concluded as this way. How we have written this? So what is the molar mass of A? How we'll calculate the molecular mass of AB2 or the molar mass of AB2? It will be molar mass of A plus 2 into molar mass of B. If we take 5 moles of it, we will simply multiply this whole thing by 5 and this 5 moles will have a mass of 125 into 10 to the power minus 3 kg. So I'm again repeating the whole thing. So it's very easy to understand. Just listen it very carefully. Suppose we have a compound AB2. Okay, we have a compound AB2. Then what will be the molar mass of AB2? It will be the molar mass of A plus 2 multiplied by the molar mass of B. Now it is written in the question that if we take 5 moles of this AB2 compound, then it will have a weight of 125 into 10 to the power minus 3 kg. So 5 multiplied by the molar mass of 1 mole. Obviously, we will multiply the 5 with this thing to get our first equation. Similarly, it is also written that 10 moles of this A2B2 is having a weight of 300 into 10 to the power minus 3 kg. So what will be the molar mass of A2B2 first of all? It will be molar mass of A multiplied by 2 because A has a factor of 2 and 2 into molar mass of B because B has a factor of 2. Now if we take 10 moles of it, then we have to multiply the molar mass of A2B2 by 10. Okay. So if we do this, we will get 300 into 10 to the power minus 3 kg, which is equation number 2. I hope you are getting this thing. Now moving on further. If we solve equation 1 and equation 2, what we will get? We will get molar mass of A as 5 into 10 to the power minus 3 mole per kg and molar mass of B as 10 into 10 to the power minus 3 mole kg per mole. So this will be also kg per mole and this will be also in kg per mole. Therefore, your correct answer will be D. Now, if anyone has any doubt, they can ask in this question. Anyone has any doubt? Yes, Gaurangi, just write your doubt. So okay. So I will try to make you understand. So first of all, let us move to the board part. Just listen it very carefully. So we have 5 moles of A2B2. And its mass is given as 125 into 10 to the power minus 3 kg. Okay, so this is your first data. Then we have 10 moles of A2B2. We have 10 moles of A2B2 whose mass is given as 300 into 10 to the power minus 3 kg. Is this clear? Is this two data clear to you? Anyone has any doubt in this data? Okay. So first of all, we will take the first line. So what will be the molar mass of A2B? Sorry, I guess it was AB2. So what will be the molar mass of AB2? It will be the molar mass of A plus 2 multiplied by the molar mass of B. But since we have taken 5 moles and this is the mass of 1 mole, because molar mass itself means it is the mass of 1 mole. So if we take 5 moles, we have to multiply it with the 5 to get the total mass of these 5 moles. To get the total mass of these 5 moles, we have to multiply the mass of 1 mole by 5. And this mass is again given as 125 into 10 to the power minus 3 kg. Similar to that, if you apply to A2B2, you will get it as 2 multiplied by MA plus 2 multiplied by MB is equals to, so this 2 is coming from the coefficient of B because there are 2 B's present in one A2B2 and 2 A's present in one A2B2. So if we write this thing for A2B2, then we have to multiply each of this by 2. Okay, we have to multiply each of this by 2. Yes, M is the molar mass of A. N2 with the 3H2 to produce the ammonia. Identify the dihydrogen as a limiting reagent in the following reaction mixture. So 4 reaction mixtures are given here and you have to identify in which of this the H2 will be present in less amount. So this was asked in the JEE exams 2019 on the 9th April of first shift. So you have some time to solve this question. Your time starts now. How we will solve this question? So we will look at each and every option one by one. Okay, we will look at each and every option one by one. So for those who have solved it, the correct answer is A, 56 gram of N2 and 10 gram of H2. How we will solve it? So in the first option, we have 56 grams of N2 and 10 grams of H2. Okay, we have 56 gram of N2 and 10 gram of H2. Then according to the equation, we know that 1 mole of N2 is reacting with 3 moles of H2 to give us 2 moles of NH3. So for N2, the molar mass of is 14, but we have to multiply this thing by 2 to balance it. So here will be 2 that will be present. Okay. Now in the next part, we will multiply H2 by 3 because 3 moles are present. So it will be 2 NH3 here and 2 N2 here. Then we have 2 moles of this ammonia. Now ammonia has a molar mass of 17. So 2 multiplied by 17, it is 34. Got it? So we have calculated the respective mass with the help of the number of moles. So students, if you balance this equation, the formation of ammonia, you will get 2. Okay. So 2 multiplied by 40. Now, according to the question, 28 grams of equation, 28 grams of N2 requires 6 gram of H2. Therefore, 56 gram of N2 will require. So that will be 6 by 28 into 56, which is equals to 12 grams. So they are our molar masses. Okay, they are the molar masses, which is 14 gram, 2 gram and the 17 gram. Then if you look it for the 12 gram of H2, so we have 12, we require 12 gram of H2, but the option has only 10 gram of H2. Therefore, H2 is present in less amount. So hence, in option A, H2 is the limiting reagent. Now, let us look at other options. So what about option B? In option B, it is written that we are reacting 35 grams of N2 with 8 grams of H2. Again, we know from the equation that 28 gram of N2 requires 6 grams of H2. Therefore, 35 grams of N2 will require 7.5 grams of H2. But we have 8 grams of H2, which is greater than the required amount. Therefore, we can say that nitrogen is the limiting reagent here, as the required H2 for N2 is less than the available H2. Now, what is the mass that is left? We have 8 grams of H2 and 7.5 is been utilized. So 0.5 grams of H2 is being left. Now moving on to the last two options, which is C and D. So in the C option, we have 14 grams of N2 with 4 grams of H2. Now again, recalling the equation, that is 28 gram of N2 requires 6 grams of H2. We can say that 14 gram will require 6 by 28 into 14, which will give you 3 grams of H2. Hence, here also, H2 is present in a greater amount than the required thing. Therefore, N2 is the limiting reagent. Coming on to the last option, we have 28 grams of N2 and 6 grams of hydrogen, which is the molar equivalent that is required according to the equation. So here, there will be no limiting reagent. So the question is, 8 grams of NaOH is dissolved in 18 grams of H2O. What is the mole fraction of NaOH in the solution, and what is the molality in mole per kg of the solution respectively? So again, this was a JEE mains question. It was asked in 2019 in 12th January in the second shift. So your time to solve the question starts now. So although this time may look small to you, but I am just giving this time so that you can analyze the question at least when I move to the answer part. Okay, so I'm getting some answers as option D. Let us move and see what is the correct answer. So what we have to do here is to calculate the mole fraction and the molality. How we'll do it? So those who have answered it, the correct answer is D. So first of all, we will calculate the mole fraction. What are the data that we are given with? We are given with the weight of NaOH, which is 8 grams. So we can calculate the molecular weight of NaOH. So NaOH is the solute here. We can say that because it is present in less amount. We have represented this molecular weight of NaOH with this MW solute or MW NaOH. So it will be 40 gram per mole. Then weight of solvent will be, which is water here. It is given as 18 gram. Then we can write the molar weight of water simply 16 plus 2, that will be 18 gram per mole. So we have the weight of the solute, weight of the solvent, molar weight of the solute and the molar weight of the solvent. Can we solve the number of moles? Let's see. So to calculate the mole fraction of the solute, which is NaOH, we will simply take the number of moles of solute divided by the total number of moles. Now in place of number of moles, we can write given weight by molar weight. Same can be written for the solute and same can be written for the solvent in the denominator. If you put all of these values, so weight is given as 88 and molar weight is given as 40. So this is substituted in both denominator and numerator. Similarly for solvent, we have 18 gram that is present and 18 gram per mole is the molar weight. So it's a very good point as we can get the number of mole as 1. If you put all of these values, you will get the mole fraction of the given solution for the solute as 0.167. So this is our first part, in which we have calculated the mole fraction of NaOH. Now moving on to the second part, which is calculation of molality. So molality can be calculated by using the formula moles of solute by mass of solvent in kg. So moles of solute, again that same formula multiplied by 1000. Why are you multiplying it by 1000? Because the mass of solvent should be in kg in case of molality, but here it is given in grams. If you substitute all the values here, you will get it as 11.11 mole per kg. Therefore, your mole fraction is 0.167 and your molality is 11.11 mole per kg. In this question, the amount of sugar required to prepare 2 liter of 0.1 molar aqueous solution is. So 4 options are given. So this was asked again in 2019 JEE Mains on the 10th January in the second shift. Your time to solve the question starts now. So I guess it's a very easy question. Now let us move to the solution. The question is asking us to calculate the amount of sugar that is required to prepare a 0.1 molar solution, and the volume is given as 2 liter. The correct answer will be 68.4 grams, which is option number B. Here is the solution. So weight of solute, I am representing this thing as B, and the molar mass of the solute, which is, I guess, sucrose here. So it will be calculated as 342 gram per mole. You can try to calculate by yourself. You will get the same answer. Then molarity is also given. It is given as 0.1 molar. So you have the say molar mass of the solute, you have the molarity, and you also have the volume of the solution, which is 2 liter. We are assuming WB as the mass of the solute. Then molarity can be calculated as given weight by molecular weight divided by the volume. So given weight is to be calculated. We are asked to calculate the amount of sugar. We will keep it as WB. Molarity is given as 0.1. So we have substituted this value. The molar mass of C12H22O11 is 342, and the volume is given as 2 liter. So here it is your 2 liter. Therefore, your correct weight of the solute is 68.4 gram. Question says that an unknown chlorohydrocarbon has 3.55% of chlorine. If each molecule of hydrocarbon has one chlorine atom only, chlorine atoms present in 1 gram of chlorohydrocarbon are. So atomic weight of chlorine is given. It is 35.5 U, and Avogadro number is given as 6.023 into 10 to the power 23 per mole. You have to know that what is the number of chlorine atom in 1 gram of the chlorohydrocarbon. Your time to solve this question or analyze this question starts now. Okay, now let us look at the correct answer. So those who have solved it, the correct answer is 0.23 into 10 to the power 20. Let us see the solution. It is written in the question that we are taking an unknown amount of chlorohydrocarbon, in which the percentage of chlorine is 3.55%. Then what we can say? So we know it from the percentage very well that 100 gram of this chlorohydrocarbon will contain 3.55 gram of chlorine. So this is the very meaning of the percentage. We do it out of 100. Now what we can say, if 100 gram has 3.55 gram, then 1 gram will have 3.55 by 100 gram or 0.0355 gram of chlorine. But at the same time, we know that the atomic weight of chlorine is 35.5 gram per mole. Then the number of moles in this amount will be given mass by molar mass, that is 0.0011 mole, 0.01 mole. Now, if we have this much moles of chlorine, then their molecules can be calculated as 0.001 multiplied by the Na, which is 6.023 into 10 to the power 20. So this is your correct answer. So in this way, you will get your option as D. Question is, the most abundant element by mass in the body of a healthy human adult are oxygen, carbon, hydrogen and nitrogen. The weight which a 75 kg person would gain if all 1 hydrogen are replaced with 2 hydrogen atoms. Options are 15 gram, 37.5 gram, 7.5 kgs and 10 kgs. So 15 kg, 37.5 kg, 7.5 kg and 10 kg. Your time to solve this question starts now. So those who have solved it, the correct answer is option C, which is 7.5 kg. Let us look at the solution. So it is given that the abundance of oxygen is 61.4%. For carbon, it is 22.9%. Hydrogen, it is 10%. And nitrogen, it is 2.6%. Now, what is the total weight of the person? It is 75 kg. Then, what will be the mass that will be due to hydrogen? If 10% hydrogen, then what is the contribution of hydrogen? It will be 10% of this 75. Okay. So it is written that out of this 75 kg, we have this much percent oxygen, this much percent carbon, 10% hydrogen and 2.6% nitrogen. That means the mass due to hydrogen will be 7.5 kgs. Okay. Now it is being written that we are replacing each 1 hydrogen atom with 2 hydrogen atom. So this 1 hydrogen and 2 hydrogen are simply the 2 isotopes of hydrogen. Okay. The one is protium and the second one is deuterium. Now, if we replace this 7.5 kgs of H1 with H2, therefore its mass will be doubled. Okay. Since we are replacing this protium with this deuterium, therefore the contribution due to the hydrogen will be doubled. And that will be equals to 7.5 into 10, 2 will give you 15. Now, this is the mass due to hydrogen 2 and this is the mass due to hydrogen 1. Thus subtract both of this to get it as 7.5 kgs. So this much amount is being increased in the human's body if we replace every protium with the deuterium. So again, I am repeating this question. Suppose a person has a mass of, now moving on to the next question. One gram of M2CO3 on treatment with excess HCl produces 0.01186 moles of CO2. The molar mass of M2CO3 in gram per mole is. So this was asked in 2017 mains. Your time to solve this question starts now. So what we have to do in the question is that we have to calculate the molar mass of M2CO3. So those who have calculated it, the correct answer will be 84.3, which is option number B. How we'll solve it? So this is the equation for the reaction of M2CO3 with HCl. You will learn about this equation in the later on chapters regarding the P block and the D block. Okay. So whenever you heat a carbonate of metal with HCl, you will get a chloride of metal plus water plus carbon dioxide. Now we can say it very clearly from the equation that whatever be the number of moles this M2CO3 is going under reaction, it will be the same number which will be formed for the CO2. That is, the mass or the number of moles of M2CO3 reacted is equals to the mass or the number of moles of CO2 that is evolved. Now it is written in the question that we are getting 0.01186 moles of CO2. That means 0.0186 moles of M2CO3 was reacting to give this number of moles because they have the same equivalent. 1 mole of this will react with 2 moles of HCl to give 1 mole of carbon dioxide. Therefore, 0.01186 moles of the metal carbonate will react to give 0.01186 of CO2. One thing we can also say that if 1 gram of carbonate will react, then it will give 1 gram of carbon dioxide. Okay. But in the question it is given that 1 gram of the metal carbonate gives 0.01186 moles of carbon dioxide. It means that 1 gram of the metal carbonate has 0.01186 moles. We can say it from these three equations. Just try to analyze these three. You will get the last equation. So if it is so, then what is the molar mass of M2CO3? It's very easy. It will be given mass by the number of moles, which is 84.3 grams per mole. So in this way, you will calculate this question. So again, I am repeating it. So it's a very easy question. So I will try to move quickly because we are lacking time. It is given that we have to find the ratio of number of molecules if the ratio of mass of oxygen and nitrogen is 1:4. So this was asked in the 2014 mains. Your time to solve this question starts now. Okay, now let us look at the solution. The correct answer will be B, which is 7:32. How we'll solve it? If we consider NO2 as the number of moles of oxygen and N2 as the number of moles of nitrogen molecules, small m O2 as the mass of oxygen molecule, and small m N2 as the mass of nitrogen molecule, then we know that the molar mass of O2 is 32 gram per mole and the molar mass of N2 is 14 into 2, that is 28 grams per mole. What are we interested in? We are interested in calculating the ratio of number of the molecules of O2 to N2. So its ratio will be same as compared to the moles. So you will get the same ratio. If it is so, then the moles of O2 in the ratio to moles of N2 can be calculated as mass of O2 divided by the molar mass of O2, which is the number of moles of O2, and moles of N2 can be calculated as mass of N2 divided by the molar mass of N2. Put all of these values, you will get the ratio of number of moles. So this will be equal to the number of molecules ratio. So with this, we have completed the question. So it's very easy to calculate. Abhi. So what is the number of moles of O2 that we got? To number of moles of N2, we got this ratio as 7:32. Okay, so we can write it as 7/32. Now what is the formula to calculate the number of moles of O2? Number of molecules of O2, it will be number of moles of O2 multiplied by the Na. So that would give you the number of molecules of O2. And that same thing with the N2. So 7/32. So they both will get cancelled out and you will get it as 7/32. Okay. Yeah. So this was all for today's class. I hope you enjoyed the lecture. Thank you.